Example 5, testing a conjecture. So if we remember, a conjecture is our rule used in inductive reasoning, and it's unproven. So what we want to try to do to test a conjecture is see if we can come up with examples and see if those examples fit the rule. If we do it for enough examples, we can say that our conjecture is true. We can't prove it's true because you would have to go through every possibility in order to prove that it's true. So if we go through enough and it works for all of them, we're going to say it's true. And if we find just one single counterexample showing that it's not true, we're going to say the whole thing's false. So our first example here says a polygon with 4 congruent sides is a square. Okay, so you have a square, it's got 4 sides. Okay. Now, if we say that this has 90-degree angles, then yes, it's going to be a square. Okay, but if we have a rhombus is defined as also having 4 congruent sides, but it's not a square because it doesn't have 4 right angles. A square has both 4 congruent sides and 4 right angles. The rhombus has 4 congruent sides but does not have 4 congruent angles. It doesn't have 4 90-degree angles, so it is not a square, but it has 4 congruent sides, so we can conclude that this conjecture is false. A rhombus is a counterexample. It shows that you can have a polygon with 4 congruent sides that is not a square. So this one would be false. Okay. And then if you click on this, drag this down, they tell you the rhombus is a good counterexample. All right. The next example. Okay. It says if a number is a multiple of 9, the sum of its digits is a multiple of 9. So let's look at several multiples of 9, and then we'll add up their digits and see if they add up to 9 as well. All right, so how about 27? All right, 3 times 9 is 27, so that's a multiple of 9. We know that 2 plus 7 equals 9. All right, so that's true. Pick another one. How about 243? Right? What is that? 27 times 9 is 243, so that's a multiple of 9. If we add these all up, 2 plus 4 plus 3, that's going to give us 9. We could do 300. I'm sorry, let's try 900. Right, 9 times 100 is 900. 9 plus 0 plus 0. Okay, it's 9. And we could continue 18, right? 18, 1 plus 8. 27 is 2 plus 7. We could do 9 times 4 is 36. 3 plus 6 is 9. 9 times 5 is 45. 4 plus 5 is 9. 9 times 7 is 63. 6 plus 3 is 9. 9 times 8 is 72. 7 plus 2 is 9. 9 times 9 is 81. 8 plus 1 is 9. So we could try all of those and we would find that this is going to be true. You're not going to be able to come up with a counterexample here. So we're going to say that this conjecture is true. Okay, at least for the cases that have been tested. True for at least for the cases that have been tested.